Okay, so yesterday we've already done the front side. That's on one of the videos prior to this. And then yesterday we did the left side. So you'll need to look at that. Here we changed the starting amount from 3 to 5, but we still did the same rate. So that just made the graph translate up. Then the next one we started at 1 rather than 3, so that translated it down. And then the third one, we doubled it. So when you double, you're multiplying times 2. And so that is actually going up at a slower rate. Now for number 4, we are starting at 3 again, but this time we are multiplying by 10. So our new rule is f of x equals 3 times 10 to the x. So let's create our xy chart, the table. So we have 0, start out with 3. And then on day 1 means the previous is being multiplied by 10. So 3 times 10.
30.
Good. Then the next one, 30 times 10 again. 300. Then the next one.
2,000.
Yep. So it's going to keep on increasing by a multiple of 10. So let's write what we changed. We changed the rate. So let's graph it. It still starts at 0, 3, but then it's 1, 30, 10, 20, 30. So it should be right here. And then 2, 300. Whoa, I can't even fit that. So make sure you make it look like a curve because it is increasing really rapidly. And the left side's going to do the same thing. And in our calculator, we have the original one. So I put in 3 times 5 to the x. We did our window like this. So make sure your window's done like that. And then we're going to go to y2 and put in the new function. 3 times 10 raised to the x value. So when we graph it, see how fast that goes? So it increases really fast. Or I guess faster. Increases faster. Mm-hmm. Yeah, you should be able to copy and paste them. Then you just do, I think it's control C. And open it up and then hold 2 minutes down and paste it. Okay, so our domain is the same as the others. X is all real numbers. It goes from negative infinity to infinity. In the range, remember how yesterday it got closer and closer to the x-axis, but it never went below? So y has to be between 0 and infinity, which we can actually write this easier than that. If it's between 0 and infinity, that means it has to be greater than 0. It can't be equal to it because it's just like walking to the wall. You can get closer and closer and closer, but you can never be at 0 distance from the wall. Okay, let's go to the next one. We are going to start at a different amount. You with me? We're going to start this time at 8. And instead of doubling or multiplying by 5, we're actually going to decrease by a half. So if I say divide by 2, divide by 2, what do you multiply if you divide by 2?
Negative?
It'd be positive. Huh? Half, yeah. So our next is going to equal now times a half. So our rate is half. It's like a half-life. Something is decaying. It's going down. So f of x equals, our first number was 3, but now it's 8.
8 times a half.
Yep, 8 times half raised to the x. Half is our new rate. It's actually decreasing. So let's write what we changed. What was the first change that we made?
Change your start.
Yeah, my start, which will end up changing my y-intercept. So my starting amount. And then what else did we change?
Rate.
The rate is now half. Yeah, it's in the base of the x. Yeah, with the exponent of x. All right, so let's do our xy table. So I'm starting with 0. 0 days. And then I start with 8 viruses. So complete the table. I don't know where it went. It just reloaded for some reason. So on day 1, it was 8, but now I'm halving it every day.
And 4.
So 4, and then 2,
1.
1.
and then
0.5.
0.5. So it'd keep on decreasing. So it's kind of like when someone takes medicine. The medicine starts out in your body, and as the day goes by and your body is using it, the medicine that is still in your body decreases. It's called half-life. So it starts out at a really high measure, really high dose in your body, but your body starts to use it, so it decreases the amount that's left in your body. Okay, so let's graph it. 0, 8. Yeah, about it right there. 0, 8. And then 1, 4. 2, 2. So right now, I can kind of see a curve, but not really. So I actually need to go to the other side of the y-axis. I need to go to those negative x values. So whenever I go to the right, it's decreasing by half. So how can I find the one prior to it? Up.
Do the opposite.
Do the opposite. What's the opposite of halving something?
Multiplying.
Multiplying by what?
2.
2. So what would this other one be? It's at 8. What would be the previous one?
Negative 1, 16.
How'd you get 16?
Because 8 times 2 is 16.
Right. So negative 1, 16. Because whenever you go to the right, 16, what's 16 divided by 2? 8. What's 8 divided by 2?
4. So then it would be 2.
So now we're going
2,
the opposite way, so we're
be-
multiplying by
The next
2.
would be negative 2, 32.
Right, because you're doing the double of 32. So 20, 32, maybe right around there. Negative 2, 32. And then what would the one before that be?
32 would be 64.
64.
Negative 64.
So it'd be like right around there. So if we connect the dots, make sure that you can see the curve.
That's like.
Yeah. What does that represent? Hmm? All right, so let's graph this. Go to y equals, we're going to change y2 to be our function here. 8 times half x. 8 times half raised to the x power. Put it into your calculator. You can do it during class.
Okay.
Yeah, I'll do that for them.
All I need to do then is answer the question. Wait, from that, like, how specific? Or, like, what do you mean?
You should read the question and look at your chart and be able to explain.
Don't you have to,
The cost weight, I mean the cost.
So kind of talk it out and then write it down. Type it up. All right, so whenever we graph it, that's not enough for me to see anything.
you have to zoom,
Zoom
out.
out.
don't you?
Yeah, I can zoom out. So zoom. I gotta wait for it to finish loading and then hit zoom.
That's gonna take a while.
But I want to scoot over a little bit. See more.
Zoom what?
Zoom out.
Oh, there you go. How do you do that?
What do you mean? How did I do it?
Like, how did you get to where it's like perfectly back where it was?
What?
I scooted my cursor. Whenever you do zoom, let's say I want to zoom in. I want to be in the middle.
Yeah, like.
Oh, that looks even better. I like that.
Oh, yeah, that.
Where's your other one though?
It's when-
Okay. All right, so this looks pretty good. So I zoomed out and then I zoomed back in and I moved my cursor.
That-
And wherever you move your cursor, that's where it zooms in or out. All right, so what happened? How is this one different from all the other ones?
Because it's not even.
Say that again. It went down. Yeah.
Well, it plus it went the other way.
Yeah, so it's more of a decrease rather than increase on all these. And the only thing we changed that was different from anything else was this half. That being less than 1. That caused it to be a decrease. It's pretty cool. But what about domain? Our x values? Our x values can be anything. So that's all real numbers again. But then our range, the range still stays above the 0 for our y. So y is still greater than 0. Okay, our last thing is to make some conclusions. So number 6 says, which changes resulted in a change in steepness of the graph? So let's specify which graphs had a change in steepness.
When you doubled it.
Okay, so like number 3?
Yeah.
So 3 because we doubled it. Graph number 3. What else? What else had a change in the steepness?
The numbers was for 2.
What causes a change in steepness? So this was translated
The
down.
change of your rate.
Change in your rate.
That's what
So-
changes the steepness.
Yep. So number 4 had a change in rate. It's now 10. And number 5 had the biggest change, which was half. So if I were to kind of make a conclusion about a function, f of x equals a times b to the x. That's kind of the general form. What value, A or B, changes the steepness?
A. No, B.
B, what is B called?
Wider.
B is our rate.
I don't know. Oh.
Rate changes steepness. Because that's your second number. When we changed our steepness, that's what we changed. Write that down. Okay, what about when we had a change? Which changes resulted in a change of the starting point of the graph?
2 and 1.
Change in y what?
Intercept.
Intercept, yeah. So which ones had a change in the y-intercept?
Number 1.
5 and 4.
Number 1 did.
Number 1. Number 5, you're right, but what was the other one?
2.
Number 2.
2, yeah. So with that function, f of x equals a times b raised to the x power, which letter changes the starting point? A. So A is your start. It's also called your y-intercept. Okay, last question. How does exponential growth compare to linear?
Oh, because linear function.
Exponential.
Hold on, let's let Trey answer first.
Linear functions deal with straight lines and make them occur.
Yeah, you're right. So straight line is linear. These curvy lines are exponential. I'm just going to put exp. How does the growth compare though?
Everyone,
One with
because it goes up.
one uses addition, subtraction, the other one uses multiplication.
So whenever you multiply, how does that change how fast it goes?
Because it goes up really.
Yeah, it goes up a lot faster. So I've put exponential growth is rapid. Kind of like the rumors. Rumors fly really quick. That's exponential. Especially if you're a small school. But then linear, is linear growth as fast?
No.
No, it's more of you're just 1 or 2 or whatever at a constant rate is a constant increase. So it's increasing by the same amount every time. Okay, you're going to glue this in your page, in the next page in your journal, and then we have an assignment that's linear, exponential, or neither. You're going to decide.
It's not gonna be easy.
It's not bad.
It's on page 88.
88.
What are we talking about?
So is that done, Kristen?
Yeah.
Why didn't you turn it in? Here, turn it into me, since I've already taken it up. Yeah.
What do we title this?
I titled it parameters of exponentials.